So using those limit properties can be pretty tiring. It can take a long time. It's a lot of writing, and who's got the time for that? There's so many math problems that we've got to do. It's just, why waste all of our time on one? So this theorem right here allows us to speed that process up greatly. It says limit as x approaches c of f of x equals f of c for any polynomial function f, and limit as x approaches c of r of x equals r of c for any rational function with a non-zero denominator at x equals c. So what does all this mean? This means, right here, in other words, that we can evaluate limits of most algebraic functions by plugging in the x value that we're approaching. And I made a note here that this also applies for one-sided limits too. So for the vast majority of the functions that we're going to be working with, to evaluate the limit, we can just go ahead and take that number, plug it into our function, see what we get back. As long as we don't run into trouble, and that's why I have this underlined with a non-zero denominator. Now, if we run into trouble, if we end up with things like, say, a 0 in the denominator or a negative under a square root, then we've got some problems. And in that case, it's not going to work. We might want to look at the graph in that case or use a different method. But for most cases, as long as we don't end up with one of those two cases, right, dividing by 0, negative inside of a square root, we should be good to go. So let's take a look at some examples. So first up, I've got limit as x approaches negative 1 of 4x cubed minus x squared plus 3x plus 2. So I'm just going to take x equals negative 1 and plug it into my function. 4 times negative 1 cubed minus negative 1 squared plus 3 times negative 1 plus 2. So I'm just going to evaluate this and see what I get back. Here I'll end up with 4 times negative 1 minus, this will be 1 minus 3 plus 2. So let's see, negative 4 minus 1 minus 3 plus 2. Here, let's see, negative 5, negative 8. Looks like I'll end up with negative 6. That is my limit. There's nothing else I really need to do there. As long as I don't end up dividing by 0 or with a negative under my square root, I'm fine. So that was an example of a polynomial function. Let's look at a rational function up here. Next, it says limit as x approaches negative 2 of x squared divided by x squared plus 1. I'm just going to take x equals negative 2 and plug it in and see what we get back. So here in this case, negative 2 squared divided by negative 2 squared plus 1. Be careful with your negative signs here. Negative 2 squared, remember, is negative 2 times negative 2, which would be a positive 4 over positive 4 plus 1. Here I end up with 4 over 5. I don't have a 0 in my denominator, so that's my limit. So we looked at, here's an example of a polynomial. Here's an example of a rational function. You can tell rational functions because they'll have an x both in the numerator and the denominator. They kind of look like fractions. But this also applies for root functions as well. So here I've got limit as x approaches 0 of square root of 3x squared plus 6. I'm just going to go ahead and plug 0 in for x, and as long as I don't end up with a negative under my square root, I'll have my answer. So I have square root of 3 times 0 squared plus 6. So 0 squared, that's 0 times 0. I've got 3 times 0 plus 6. 3 times 0, that's 0, so I'm just left with square root of 6, and that's my limit. For square roots for this class, please don't round them unless the problem specifically asks you to. If you can simplify the square root, then by all means go ahead, but square root of 6, that's not a perfect square. It's not going to work out nicely, so we'll just leave our answer for now as square root of 6.